first thing we're going to do is find the area of a triangle. So, or I mean, that's the main thing we're doing today, is learning to find the area of a triangle. Okay? You've probably learned before in geometry the formula that says area is 1/2 times the base times the height. Okay? The problem is sometimes we know the sides of a triangle and we don't know the height of it. Unless it's a right triangle, then the height is easy, because in a right triangle the height is also one of the sides, right? So this works well for right triangles, because then you can put it so that your right angle is making so you have your height one way and your base the other way, right? But it doesn't work so well for oblique triangles if you don't know the height. So typically what you would have done in geometry if you didn't know the height was you'd have to use something like Pythagorean theorem or SOHCAHTOA. Maybe you didn't do problems even this hard in geometry, but if you did, you would have had to use SOHCAHTOA to solve for the height of the triangle, and then use that height to find the area of the triangle, right? Well, guess what? We have actually a formula that does the same thing. I'm going to actually prove the formula to you using this formula, but let's just start with it the way it is. This is for SAS information for triangles. So if you have a side, angle, side, this is what you would do for that type of triangle if you have a side angle side triangle. Now here's what I've seen some people do on the test. They haven't read the instructions carefully, where it said find the area of the triangle. Instead they just assumed they needed to solve the triangle, so it's angle side angle, and they suddenly jump into using law of sines and solving it instead of just finding the area. Okay? So make sure on a test or whatever you're doing when you have problems mixed together that you're very careful to pay attention to what it's asking for. Okay, there are 3 different formulas to find area. Of course, it's really all just one formula. It just depends on which letters you're using for that particular one. So it really isn't 3 different formulas to memorize. It's really all the same formula. Just I've written it down here if I can write and talk at the same time. Sorry, that one's misaligned from the others. Because I forgot the 1/2 at first. So notice how it's just with the different letters. But as long as you realize that it's just you're using a side and an angle and a side. So the angle is the one that's not across from the 2 sides. That's the information you have to use. Then it really doesn't matter if you memorize each one individually or not, because it's just the same pattern the whole time. Okay. I'd like to look, well, do you want to see a proof of the formula first, or would you like to see just an example? We could do the proof later if we have time. Is that better? Okay. Let's just do a quick example. So let's say A equals 8, B equals 6, and gamma equals 30 degrees. How would we find the area for that triangle even though we don't know the height? We just know 2 sides and an angle. So area is 1/2 8 times 6 times the sine of 30. Sine of 30 is 1/2. Good job. Yep. So 1/2 of 8 is 4 and 1/2 of 6 is 3. So 4 times 3 is 12. 12 square units. Okay, what if they don't give you side angle side information? You could solve the triangle so that you have side angle side information. That's a good idea. I actually have a different formula we can use for side triangles. Okay, so are we good with this? You don't need a further example? Because they do get trickier than this. If they don't give you side angle side, you have to find another piece to be able to do it.
And do you use that with
Yeah, so you would use what we learned the last couple of days to solve for another piece of the triangle so that you have side angle side.
So all you need is two sides and then
It has to be the angle between the two sides, so you can't use opposites.
okay, so
It has to be a side angle side situation with the angle between the two sides. So you have to solve whatever you need to get that information. Okay. Or alternatively, you could always solve for the height of the triangle and do 1/2 base times height. I mean, you don't have to use this formula, so unless they tell you to. So, was there another question before I move on? Okay. This one, oh, I had another example. Okay, we'll do that one in a minute. Okay. This is if you have side, side, side. This formula is called Herron's formula. Pretty sure that's how Miss Herron spells her name, so this must be named after her. Herron's formula says the area, Colby Evans? Colby Evans? Well, that's because Colby talks too much. I listen in on all of his conversations too because he's that loud and talkative. Okay. And now I'm listening in on your conversation about Miss Herron. Colby. Oh no, and I mentioned a student's last name in my video. Oh no. We're in trouble. Okay. So here's Herron's formula. We know what A, B, and C are, right? What are A, B, and C? The sides. What is S? What is this weird S we speak of? Okay. S is a weird thing. S is half of the perimeter. S is half of the perimeter. So what do you typically do to find the perimeter of a triangle? Add the three sides together, and the three sides happen to be A, B, and C. So half of the perimeter is half of A plus B plus C. And then it's used all the way through the formula. Okay, let's do an example. Find the area if A equals 4, B equals 5, and C equals 7. Do you want to go ahead and try it on your own first? I know you guys can use formulas. So go ahead and try it on your own, and then I will check it with you in a few seconds here. While you're doing that, I'm going to be writing up another problem that we'll be doing in a minute. So do you guys have this information written down, okay? Can I flip the paper over and write something else? All right. Yes, everyone has the information they need? Okay. By the way, I haven't specifically said this, but you guys should probably create some cards for your little flip notes. Some cards, one for law of sines, one for law of cosines, one for area. Right? So just a reminder of something you should probably do. let's check our answer. We ready? So first we find S by doing half of 4 plus 5 plus 7, which is half of 16, which is 8. Then we find the area by doing 8 times 8 minus 4 times 8 minus 5 times 8 minus 7. So you can plug the whole thing in your calculator, but it ends up being 8 times 4 times 3 times 1, which is the square root of 96, which is about 9.8 square units. Did we do okay? Good. Okay, now we're going to do an application problem. Are pieces of land always nicely square or rectangular and easy to find the area of? No. In fact, the property I'm on is a really weird shape, but it's okay. All right, so let's suppose you wanted to find the area of something, land to plant grass or something, because when you order lawn sod to lay in a certain area, you have to approximate the number of square feet you need. Okay? So you need to be able to get a fairly accurate result so you don't run out of sod or have way too much left over, right? So we have this strange quadrilateral shape. It's not even a parallelogram because none of the sides or angles are equal. Any ideas? Problem-solving skills. Split it into 2 triangles and find the area of each triangle. Beautiful. So which way do you want to split it? This way or that way?
91.5 and 87.2.
You want to split it this way?
Is it a bisecting segment, so just half that angle?
You know what? You don't even need those angles because you have a side angle side, side angle side.
Oh, good point.
So it doesn't even matter.
Good point.
Doesn't matter which ones, what you're cutting through and what they are. If you want me to be able to check your individual work easier, we should split it this way because that's the way I did it on my paper, so I have the answers to that. But if anyone wants to experiment and split it the other way and see if you get the same answer, that'd be fine too. Okay, so I'm going to split it that way just because that's what I have on my paper, so we're not going to worry about that angle or that angle. Okay? Alright, so let's call this triangle number 1 and triangle number 2, and then we'll add them together. So the area of triangle 1 would be 1/2, 148.7, 93.5, and the sine of 91.5. And the second area would be 1/2, 100.5 times 155.4 times the sine of 87.2. And then we get those two numbers and we add them together and get a total. I'm sorry. What'd you get? Do you get the idea? I don't need to hold you over to finish it. So there's the answer I got for that. So it wouldn't matter though if you split it the other direction. You should still end up adding up to the same answer. And I guess we didn't do the proof, so the proof will have to be later. Maybe I should give that as homework. Prove the